Hello, welcome to this video on the concave mirror. In this video we will prove that for a concave mirror the radius r is equal to 2 times the focal length f of the mirror. So I will assume that you know the basics of the concave mirror. If you don't, then I suggest you watch the video that I've created on the basics of the concave mirror before you watch this video. So we have here a ray of light arriving parallel to the optical axis. So this ray of light here, PA, is parallel. PA is parallel to the optical axis, so x dash. And we know that such rays, when they reflect off the mirror at this point A, the reflected ray will pass through the focal point of the mirror. Okay, like this. And recall from your previous knowledge, hopefully, that this dashed line here, AC, this is the normal. This is the normal line to the mirror at A. So let me write that here. So AC is the normal Okay, so with that we're ready to start our proof. So the proof proceeds as follows. Let us call this angle here, let us call this theta. Okay, so we are saying that angle PAC is theta. Now, because PA is parallel to x prime, this line here, that means that this angle here is also going to be equal to theta. So this angle here is the same as this angle here. This angle here is FCA, angle FCA. And as I said, this is because PA is parallel to x prime. So hopefully you can recall that when you have this kind of shape, when you have a shape like this, where this side here, or this line here is parallel to this line here, that these two angles, this angle here and this angle here, are the same. Okay, so that's a rule of geometry, and that's all we are using here. We are saying that this angle is equal to this angle because this line here is parallel to this line here. Okay, now we also know that this angle here, angle FAC, we know that this angle is also equal to theta. Let me draw that in. Now, How do we know this? Recall that I said that AC here is the normal, and hopefully you recall from the concept of reflection that what we are dealing with here, these angles here, are the angles of incidence and reflection. If you need reminding of these top concepts, please check out the video I've created on the laws of reflection as a reminder. So what we are saying here is this angle PAC is the angle of incidence, I. Okay? But we know from the law of reflection that this angle of incidence will equal the angle of reflection. But the angle of reflection here is just angle FAC. Which implies that FAC is theta. Okay, because PAC, we said at the beginning that PAC, angle PAC, is what we are calling theta. Okay. Now, if you look over here, you can see we have a triangle here. Now notice that triangle ACF it has two angles which are the same, right? This angle here and this angle here. So therefore that means that this triangle is isosceles. Meaning that two of its sides will be the same. Okay, so that means FA will equal FC. Now, this point A, let us assume that it is quite close to point O, the center of the mirror. Okay, so we effectively are assuming that this light ray comes in and hits the mirror quite close to the center of the mirror. So let's write that. So if this is the case, let me write if A is close to O, what this implies is that FA will be almost equal to FO. Okay, so just imagine if I had drawn A here, okay, then this line, this length here, FA, you can see that it would be quite close to FO. I haven't drawn it here just to keep the diagram clear. Okay, so we're saying if A is close to O, then FA is approximately equal to FO. Now, recall from the basics of the concave mirror that FO here is just the focal length. Okay, remember this distance from the focal point to the center of the mirror, that is F. Okay, so if we put these two things together here, if we're saying FA is approximately FO, or let's just say equal to FO, then this means FO is equal to FC, meaning we can say that FC is equal to F, the focal length. Now, we have almost come to the end of our proof, because all we need to notice now is that the distance from the center of the mirror to the center of curvature, or the center of the circle or sphere, OC, okay, so OC here, we know that this is equal to FO plus FC. Now, what do we know about these things here? As we said, FO is just the focal length, so this is F. We also proved here that FC, this distance from here to here, is also F. So that means F plus F is 2F. But OC, this is just the radius of the concave mirror. So we can call this R. And let me point out that this R here, this is the radius. This is completely different from this R that I used here. This was an angle, the angle of reflection. So please don't confuse this R with this R. So in other words, we have proved what we set out to prove, that for a concave mirror, the radius of the concave mirror is equal to 2 times the focal length of the concave mirror. And you must learn this because it could easily come up in your exam. So you need to know this proof and learn it well. So I suggest you go through, once you've gone through this video, you try to do the proof yourself. You don't look at this video and you try to prove this yourself. Okay? Let me also just add that this relationship between R and F, this is also true for the convex mirror. Okay, so I won't prove that here, but you should know this. Thank you for listening.